All right. I am going to grab the table, gentlemen. I'm going to grab the table from cosine. So we talked, sorry guys, we talked briefly about where graphs start, and I kind of just blew through that. So let's see how much you remember. So I'm doing the basic graph of y equals cos x. And when I said where do they start, I'm going to start at 0, and then I'm going to go to positive pi over 2, and then I'm going to go to pi, and then I'm going to go to 3 pi over 2, and 2 pi. So the very, very basic cos graph, the very, very basic one, no transformations on it. It's like your y equals x squared. Where does a cos graph start? And I said it starts at a maximum. So it's going to start at the top of a wave. And on the very, very basic graph, what is the maximum y value? 1. So when I say a cos graph starts at 1 with no transformations, we always start at 0, right? We start at 0 and we work forwards, we work backwards. So if we start out at a max, we're starting at 1. And this is the table from yesterday's notes. Not yesterday, day before. So I'm just trying to do it without looking at my notes. But I know cos graphs start at a max. So cos graphs start at a max. So I know at 0 it will be 1. And so if I'm remembering my unit circle, I'm looking for x values of the coordinate pairs. So at pi over 2 at 90 degrees, I'm at 0. And at pi, what's the x coordinate at pi? -1. You guys remember the pattern? And at 3 pi over 2, where am I going to be? 0. And then at 2 pi, so I'm back where I started. 1, right? +1. Okay, now let's work backwards. I'm starting at 0, and I'm going to go negative pi over 2. So I'm down on the y-axis. 0. Okay, that's the basic cos graph. Are we good to graph that one? Okay. All right, let's put those points on there. Are you guys comfortable doing the increments on the basic graphs, maybe, sort of, kind of? Because it's going to get uncomfortable. Okay? In 5.3, and I saved 5.3 a little bit in 5.2, but definitely uncomfortable in 5.3. I saved 5.3 until I got back. So I flip-flopped the lessons. I didn't want to do 5.3 without me here. 5.4 is just graphing reciprocal graphs in the tan graph. All right, I'm going to graph this stuff. Starts at a max, then I go to a median, then I go to a minimum, median, maximum, median. So I'm using different language. I'm not even using zeros and ones and negative ones. I'm using that max value, that min value, and the median value, that middle line of 0. So starts at a max, goes to a median, goes to a minimum. You can't jump from a max to a min. You have to hit the median on the way back. And it's just a pattern, right? Okay, where's my arrow pointing? Up or down? Should be pointing down because I'm at a max, so my next point's going to be headed somewhere down towards a median. What about here? Up or down? Also down because I'm not quite at a minimum yet. Okay. So that's my y equals cos graph. We did that Wednesday, so I'm sure we're all feeling super confident with that. Like I graphed it once. I don't know what you're talking about. All right, so now we're going to graph two more graphs on the same axis. We're going to graph cos of 4x. Oh no. Oh no. What did we do on the other ones? We did vertical stretches, right? We multiplied the y's. What are we doing here? Where's the number attached to? It's on the horizontal. So we're doing horizontal stretches. So we're timesing our x's for the very first time. Okay, so if it's 4x, no big deal. This is just chapter 1, but we're applying it to a function, to a trigonometric function. So what's that 4 telling me to do? By a factor of 1 over 4, right? Because the x never tells you the straight story. So we're going to be multiplying x's by a quarter. Well, that's terrible. I probably should have made my increments a little bit nicer, but that's okay. I think maybe it might be helpful to do a table of values for this, just so that we don't get too lost in it. So the y equals cos 4x. The y equals cos 4x. Anything happening to my y's? No. Do you guys like putting those in first? Sometimes I find that a little confusing to myself, but it's okay. It's okay. We'll be okay. So really what we're going to do is we're going to take our x values and we're going to times them by a quarter. So negative, maybe let's start at 0. What's 0 times by a quarter? 0. So that value is going to be 0. Let's go here. So pi over 2 times by a quarter. Pi over 8. Pi over 8. And pi times by a quarter is going to be pi over 4. 3 pi over 2 times by a quarter is going to be 3 pi over 8. This is going to be a very squishy graph. I should have made my increments a little bit wider. And 2 pi divided by 4. Pi over 2. Okay, so let's work backwards here. Negative pi over 2 times by a quarter is going to be negative pi over 8. Woo! That's squishy. It's very squishy. All right, maybe we'll grab a pink pen. Maybe I'll grab a pink pen to graph this one. I have a green pen. Can you kind of tell the difference? We'll see. I'll do it with a pink pen. Okay, so 0 and 1. That point doesn't change. 0 and 1. I'm going to do my positive stuff first, and then I go back and do my negatives. It's a habit I have. How you choose to graph. Some of you like to start at the top of the table and work down because that's what's in the table. You are my people. You're linear thinkers. But I'm going to start and do all my positive ones first. Okay, pi over 8. Ladies and gentlemen, right here is pi over 4. Where's pi over 8? It's right in between. It's right in between the 0 and pi over 4. So that's pi over 8 right there. So at pi over 8, I'm at 0. Ooh, that's squishy. My dot's almost as big as my increment. And then I'm going to pi over 4, and that's at negative 1. And then I'm going to 3 pi over 8. 3 pi over 8. That's right in the middle here. Because that would be 1 pi over 8, 2 pi over 8, 3 pi over 8. Right? If I get common denominators. And then pi over 2. I'm back at 1. And this one, negative pi over 8, which is right in between, I'm at 0. Holy Hannah, that is a squishy graph. Arrows are still all pointing down. I find getting common denominators when I'm graphing probably the easiest thing to do. So here I might have written this as 2 pi over 8. This I would have written as 4 pi over 8. We're always big on reducing, but sometimes with graphing, it's easier to have equal increments. Okay, how does that feel besides being really squishy? Not terrible? Kind of terrible? All right, don't all jump up and say the answer at once. Okay, the next one, what is the 1/2 telling me to do? Yep, so I'm going to multiply my x's. By 2. So we're going to have a horizontal, let's use the correct language when we're describing it. We have a horizontal stretch by a factor of 2. Anytime we're multiplying, it's by a factor. Factors are associated with multiplying. So by a factor of 2. This is kind of, we're doing a verbal or a written mapping rule here. Again, nothing's happening to, I'm just going to put my next table right over here. Nothing's happening to the y's. Nothing's happening to the y's again, except there's a hole in the way. So 0, 1, 0, negative 1, 0, 1. Sorry, I'm just avoiding the hole in my paper. And we're going to go back to the original table. Still not far enough. We're going to go back to the original table, and we're going to multiply our x values by 2. So where am I going to be on this one?
Negative pi?
Negative pi. And 0, I'm still at 0. That's exciting. Pi over 2 is going to be a positive pi. 3 pi over 2. 3 pi. And did I miss one? I missed pi. Sorry. That's going to be 2 pi. Sorry, I missed pi. So I'm timesing that by 2. 3 pi over 2 will be the 3 pi. And my last one, 2 pi times by 2 is 4 pi. So what do we anticipate with this graph? It's going to be really stretched out. We're going to have a really far stretched out graph. So I'm going to have to add some increments on here. Not the end of the world. So I go 1, 2, 3, 4. 1, 2, 3, 4. That is 3 pi. 1, 2, 3, 4. That's 4 pi. I'm not going to label the increments in between because on this graph I actually don't need them. Okay, here we go. Negative pi and 0. Do I have enough room for negative pi on here?
No.
No. Oftentimes we'll create a table with extra data in it. It's okay that we're not going to graph that point. So my very first point is going to be 0 and 1. So that point stays. That point just keeps getting bigger every time I circle it. Then we're going to pi and 0. And then we're going to 2 pi and negative 1. We're going to 3 pi and 0. And we're going to 4 pi and positive 1. Putting them all on the same graph is hard. Okay, which way are my arrows going? On the right-hand side, where am I going? Going down because I'm at a maximum. And here, I'm going to be going down because I'm at a maximum as well. So this one's my y equals cos 1/2 x graph. Okay, I need to flip back to the other page. So whenever you're done graphing, I'll flip back. Are you cool if I flip back? All right, so this was the one we did, and yeah? Yeah. Oh, yes, sorry. There's too many things going on there. There was Logan, I thought you were indicating to me that it was, somebody needed me, but they needed Logan. Okay. All right, I just want to flip back to that graph that we did on Wednesday. We talked about these, and we talked about the vertical stretches. We talked about a vertical stretch. So we were here multiply y's by 3, right? Oh, sorry, you can't see it. So what we did was we stretched that graph. So what does this do to the graph? Like this one was my original, the light blue one here. The light blue one was my original. What did that multiplying by 3 do? What did it do to the amplitude of the graph? It multiplied it by 3. So vertical stretches affect amplitude. Effect? Affect? Which one, my English people? Effect, affect. Which one?
Affect. Affect is the verb, effect is the... Affect is the verb. If you affect
Because the affect comes after the effect.
Effect is the...
I think the effect is the multiplying by 3, and the affect is the result of... Okay, so we're affect. All right, good job. Look at us, English people.
This course is affecting me,
Yeah.
and I am affecting the book.
That made no sense. It's
I
okay.
think those hard drugs are affecting his brain.
Okay,
Learn something hard.
so vertical stretches affect the amplitude after the effect of multiplying. I'm going to ask again, don't worry. So remember this, you guys have younger brains than I do. All right, so you can find the amplitude of, okay, can you see it here? Do you know what the amplitude of this wave is? 3. Do you need to math it out? No. But if you are lost and you have a graph in front of you and I tell you you have to create the equation of it, hint, hint, nudge, nudge, that's 5.3, and you don't know what to do for that amplitude, all you have to do is take the maximum value, subtract it from the minimum value, and divide by 2. So you're telling me on that graph, my maximum was 3. I'd subtract the minimum, which was at -3. So that's the way to math it out. Oftentimes, you can just look at the graph and see it. Does that make sense to everybody? Like, you don't have to show me the math, but you might find this helpful when we get to 5.3 and I give you a graph and I say create the equation. Okay, so this is like a little back pocket kind of secret thing. This isn't anywhere, this is something that you have to know. This whole course is, this isn't anywhere, and it's something you have to know. Okay, so here we go. When we multiplied by a quarter, what happened to the period? We went from a maximum, like we go from, on the blue graph, if we go from a maximum to a maximum, we know we have a period of 2 pi. The basic coast graph has a period of 2 pi. If we are multiplying by a quarter, now we're going from a maximum to a maximum. What happened to our graph? The period got much smaller. So horizontal stretches affect the period. Oh geez, you guys can't read anything I'm writing. I recorded a video last night for next week when I was away, and I didn't like it, so I'm gonna end up having to do it again. The first day on the 11th, I'm gonna hand you out new notes for 5.4. I needed to make more values in the tables, so I did it in the booklet, but I'm like cramming numbers in and it just didn't feel right. So I'm just gonna hand you out a new set of notes, or the sub will hand you out a new set of notes. So don't be alarmed and say, oh, we already have these. You do have them, just a couple of the tables aren't the way I'd like them to be.
By the way, where are you going?
I'm going to Winnipeg. I have a mathy meeting.
Sounds very nice.
It sounds like a great time. I know you're all jealous. Okay, to determine the period of a function, like here we can see it. Oh, sorry, you can't see it when I don't show it to you. So a maximum to a maximum is a period on a cosine graph. So we would start at 0 and we hit our other maximum at pi over 2. So the period of this squished graph is pi over 2. We've done a transformation to make it more squishy, so the period changes. So we know this period is pi over 2, from a max to a max on a coast graph. So you can use this formula to do it. The b value is an absolute, so we're doing our whole thing in radians, so we're going to use this one here. Wait till I ask you to graph these using degrees. You're going to hate it. So we would take the period equals 2 pi divided by b. So the period, and the b value is that 4. This is the b value. That's b. So we take it right from the equation. We don't take the quarter, we take the 4. So we're going to say 2 pi divided by 4. We're going to reduce that, and it's pi over 2, which we knew from looking at the graph. This is a lot of 5.3. It's a lot of 5.3. Okay.
Where did you get
Where did I get what?
Never mind.
Do you know where I got it from?
I don't, the B for period, it says 2 here, but isn't it like half a pi?
The period is half a pi.
Oh. So then what's the B value?
I just explained that. It's from the equation.
Oh.
It's the number being multiplied by the x. You take the actual 4. You don't take the quarter, you take the 4.
Okay.
B also be like 4 times the y.
No, that would be an A. That's your vertical stretches. Anything times to the y is going to affect the amplitude. Anything at times by the x's is going to affect your period. Because we said amplitude is related to the y values and period is related to the x values. So they're going to attach to 2 different things on the graph. Okay, that's a lot. Let's keep going. Let's do 2 at once, because we're smart people. All right, would it help you? Are these the training wheels that we need to do the COAS table first, like the original one? Does that help to have that? Yes? I'm going to say it does. So y equals cos x and can you fill this in without looking at any value, any table? Can you do that? We just did it on the other page. What do COAS graphs start at? Maximum. So 0 and 1. COAS graphs start at 0 and 1 when there's no transformations attached to them. Everybody got their table done? Okay. All right, now we're going to apply the transformations. Holy Hannah, there's a couple of things going on here. Really what we're going to do is we're timesing the y's, we're multiplying the y's by -3. Now, if that's the math we're doing, what can you just, I'm going to describe it, you don't have to describe it. So what does that do to the graph? If I were to ask you to describe the transformation, we'd have a reflection in the x-axis, we'd have a vertical stretch by a factor of 3, and then when we go to the back of the bus, we are multiplying our x's by 1/2.
And Miss Gallion, do we need to care about cosine in the table?
We do, because that tells us where we're starting from. That tells us that we're dealing with a sinusoidal graph. Tan graphs are going to look super different. So cos is very, very important, because that gets me my basic table. That gets me my basic table here. That's what I'm using that for. So I'm going to go over, I'm going to slide over, you can't see it. I'm going to do -3 cos 2x, so y equals, I'm going to do my table of values here. I'm going to do my table of values here. So x's are being times by 1/2. So this is going to be -1/4, 0, +1/4 pi, pi over 2, 3 pi over 4, and pi. Now I reduced fractions and I just said, yeah,
Oh, so we multiply everything by a quarter?
by 1/2.
Okay.
Yeah.
After 0, it's pi over 3. So pi over 4.
But I'm timesing 1/2 by 1/2. So it should be pi over 1/4. Okay, so now we're going to do our y's. 0 times by -3 is still 0. We'd have -3 here. We would have 0. We would have +3 here, 0, and then -3 again. Okay, I'm gonna do my increments a little bit wider this time, just so that we don't have to squish the whole graph. All right, so I'm going up by quarters, so this would be 2 pi over 4, and that would be 4 pi over 4 if I were putting common denominators. I find it easier to do my increments if I see the common denominator on them. It really depends how your brain works, whatever works best for you. Actually, what do you want to do? Do you want to spread it out, or do you want to use the increments that we were using before? Doesn't matter? You guys don't care? So see what I did there with my increments? I made them all common denominators, but we know that this simplifies to pi over 2. But sometimes I find it easier when I'm putting those ticks on the graph to do that. Okay, let's graph. So at negative pi over 4, we're at 0. At 0, oh, I didn't put any ticks on my y-axis. 1, 2, 3, negative 1, negative 2, negative 3. Pi over 2, which is 2 pi over 4. That one, I'm going to be at a positive 3. 3 pi over 4, I'm back to a 0. And 4 pi over 4, I'm at a negative 3. Looks a little weird, but not terrible. All right, let's calculate the period, and let's calculate, so for coast graphs, we know they always start at a max, and to find the period of, so we know they start at a max, and to find the period, you're going to go from a max to a max, or a min to a min. And you guys all know what I mean by max to max, like the highest point to the next highest point, or the lowest point. Because in this case, I don't have 2 maximums, but I do have 2 minimums. So what is the amplitude of this graph? What's the amplitude? 3, right? It has a max value of 3. It has a min value of negative 3. If I subtract those two, we're at 6 divided by 2. That's 3. And period. It's just pi. Conveniently, my minimum's at 0. Where's the next minimum I see? It's at 4 pi over 4, which is just pi. So oftentimes you can figure this out just by looking at it. All right, how do we feel about that? Okay, not terrible? Wait till we get into shifts. Okay, I would like you guys to tackle this one. I want you guys to tackle it. I'm going to do it at the same time. What graph are we on? Are we on cos? No, we're on sine. Where does a sine graph start? 0. Okay, so it might help you to do your basic sine table first. Okay, I'm going to freeze. You guys keep going. I'll keep going. And the video will see mine. Just keep moving on. Okay, before you get too far, is that your sine table? Okay? Because I don't want you to do transformations off the wrong table, because then that's going to be bad, oh bad. Okay, I'm freezing again. You guys are going to go. Keep forgetting my y increments. Okay, let me know when you're ready to see it. Yep, exactly. You can go to the library. All right, am I good to show it to you? Your graph might look a little different if we use different increments. Your graph might look a little different if you use different increments. So no reflection on this graph, but I'm still only seeing two minimums. All right. Okay, so what's the amplitude? Oh, you know what? I screwed up. Oh, I don't have whiteout. What did I screw up with? Anybody see it? My table, yeah. Oh, I'm doing sine. I didn't screw up. I'm good. I'm good. I was like, my coast graph is way off. My table's good. Okay, let's talk about sine. Sine, we start at a median. We start at a median. And when we're looking for the period, you're looking for a median to a max, a median to a max to a median. You're looking for 3 medians. Oh, this is confusing. To a median. So you're looking for 3 medians. Let me summarize that. That's probably easier to say it that way. You need 3 medians when you're looking for a period. I wrote more stuff than you have to. So when I look at a period of a function, here's a median, conveniently at 0. Then we have our second median at pi over 4. And we have our third median at 2 pi over 4. So our amplitude of this graph is 3. And our period, so we're 1, 2, 3 medians. You are going to be at pi over 2. I don't want you to give it to me as 2 pi over 4, even though that's what my graph says. I'm doing that for increments to help me graph more appropriately. I want this in the most reduced way because we're going to put them into equations and we want it in the most reduced form. So that's it. That's all. That took a long time.